When you take a heap snapshot, you're often looking for patterns, not just individual objects. JProfiler 15 makes that much easier. The Heap Walker now supports grouping and filtering, not just on live data, but also on dumped data. A new API lets you write scripts that filter objects or define grouping logic, and it works consistently in both live sessions and snapshots. To show what that looks like, we'll use a small Hibernate-based demo that creates different types of query cache entries. Hibernate's second-level cache can be a major contributor to memory usage, and the key question is, what exactly is taking up that space? With grouping and filtering in snapshots, JProfiler now gives you a way to answer that directly. The demo app uses Spring Boot and manages item JPA entities. The item service has several query methods whose results are cached. Note that findById literal even embeds the ID in the query on purpose to create a large number of distinct cache keys. The actual workload is executed by the load generator that first creates 1,000 items and then runs a couple thousand queries, all of which have their results cached. At the end of the run, we trigger a heap dump with the JProfiler API. Let's start profiling. After the load generator is finished, the Spring Boot app terminates. There is no web server to keep it alive, so we choose to save a snapshot when the JVM exits. This will take around 20 seconds. When the JVM exits, the snapshot is saved and JProfiler opens it automatically in place. At this point, we'll be working entirely with a snapshot. There are no live objects and no runtime state to inspect. The total heap size is 65 megabytes. To see which objects dominate memory usage, the biggest objects view is often the best starting point. Indeed, 37 megabytes are retained through the second-level cache that holds our query results. So which queries are responsible for the majority of that memory usage? The query key instances hold the query strings, so let's look at them in detail. In this example, we see a findByTenant query. With 12,000 keys, opening each one manually isn't practical. We need a way to aggregate them. That's where the new custom grouping inspection comes in. In previous versions of JProfiler, this was only possible with live data. But since JProfiler 15, there is an API to traverse dumped data. Let's check it out. The selected query key instances are regular objects, so JProfiler passes us an instance object which gives us access to the field values. The root of the API hierarchy is heap object, which provides access to incoming and outgoing references. With the field value method, we get the string reference that we're interested in, and that is represented as a string instance. A string instance has a value method to extract the actual string. Let's put all of that into a one-line script. Here we just return the query string as the group name. Now we run the inspection. There are 10,000 findByTenant queries, 1,000 findHighQuantityValue queries, and a lot of different queries that had the literal ID value in them. Selecting a group will show the associated objects. Let's look at the quantity-related queries. So far, we've only selected the query keys. To measure their memory footprint, we need to follow the references to the cached values. To understand what's keeping these keys alive, we open the Merged Dominating References view. All 1,000 keys are exclusively retained by the same path. The nodes also hold the values, so let's select them. The cached values are stored in serialized byte buffers. The total contribution to the cache size is the retained size of the current object set. We see that 28 megabytes of the 37 megabyte cache size are due to these queries, although they are less than 10% of the total query count. This makes sense because their cached values are large compared to the other queries. The selection steps show how we got here, including the group name. Let's go back to that selection step. Next, let's look at the queries that include literal IDs. One way to isolate them is by applying a filter script. With the SQL query string reference selected, we invoke the filter script action on dumped data. If we return true, the heap object instance that is passed to the script will be part of the new object set. Since we know that the reference is a string, we cast it to a string instance and use a regular expression to filter values that contain a numeric ID clause. Now let's measure their memory impact as well. The retained size for these queries is just 880 kilobytes, much smaller than that of the quantity-based queries. By grouping query keys by structure and calculating their retained sizes, we turn thousands of raw cache entries into a clear memory usage profile. With scripting support on dumped data, you can now analyze heap snapshots with the same precision as live data.